my name is Ananda Rofiqoh, and here I'm with my partner is Sofiatul Jannah. We will explain about the topic we have chosen from the article Speech Perception at Birth, the Brain Encodes Fast and Slow Temporal Information by Laura Cabrera and Judith Gervain. Speech perception is constrained by auditory processing, although at birth infants have an immature auditory system and limited language experience. They show remarkable speech perception skills. Speech perception requires efficient auditory mechanism to track subtle difference in the complex combination of spectral and temporal information, differentiating linguistic contrast. Although infants have an immature peripheral and central auditory system, they show acquired speech perception abilities from birth. How they can achieve this and whether they rely on the same acoustic information as adults remains unknown. The present study investigates whether and if yes, how newborn infants use the temporal information in the speech signal to discriminate phoneme. Temporal information plays an essential role in speech perception in adults. Speech is mainly conveyed to the brain by the basilar membranes in cochlea in the inner ear, which encodes the temporal modulation of speech signal in different frequency regions or bands. Within each frequency band, the temporal properties are expressed at two time scale. The amplitude modulation AM cues, also called temporal envelope, corresponding to the relatively slow variation in amplitude over time, and the frequency modulation FM cues, also called temporal fine structure, corresponding to the variation in instantaneous frequency close to the center frequency CF of the frequency band. This temporal decomposition is observed at the cortical level in adults. Previous studies measuring brain activation for non-speech sounds modulated in amplitude at different rates shows predominant cortical response to the lowest AM frequency 4 to 8 Hz and hemispheric specialization in temporal envelope coding, as well as a difference in time course of activation between slow 16 Hz and fast 100 2008 Hz AM rates for speech sound. The debate about the hemispheric specialization to different acoustic properties of the speech signal is ongoing, but it is usually assumed that fast temporal modulation is preferentially processed by the left auditory cortex, while slow temporal modulation and or spectral modulation is processed by the right temporal cortex. The few existing behavioral studies with infants suggest that 6-month-olds might weight modulation cues differently than adults, although 6-month-old French infants, like adults, are able to use the speech envelope to discriminate consonant based on voicing, such as a ba or apa, in place of articulation such as in aba or ada. In quiet, they require more time to habituate to speech sounds containing only envelope cues below 16 Hz than to speech sounds preserving fast modulation. This study demonstrates that the human auditory system is able to encode speech in fine details on the basis of highly reduced acoustic information. Specifically, the slowest AM cues already from birth. Furthermore, the newborn brain already shows considerable specialization to different temporal cues in speech signal, laying the foundation of infants' astonishingly sophisticated speech perception and language learning abilities.
Assalamualaikum warahmatullahi wabarakatuh. Saya Sofiatul Jannah akan membacakan jawaban hasil diskusi kami. Nomor 2 adalah apa yang menurut kamu bisa kamu aplikasikan di pengajaran kamu kelak berdasarkan artikel tersebut. Dan jawabannya adalah the present finding provide unique insight showing that the newborn brain also exhibits this differential processing for different AM rates in speech and suggests that differential hemispheric specialist for the processing of slow and fast inflow information is already present at birth. The human brain is thus already zoned to fast and slow AM information in speech from the get-go, laying the foundation of later language learning and speech comprehension. In this study, it is possible that a sharply decreased hemodynamic response in habit condition may reflect faster neural habituation in this condition than in the other two conditions. So, this deactivation cannot be caused by systemic variation in blood flow due to the slow condition being presented in a balanced order. And that way, we will apply slow and fast method when we teaching later with listening skills. Also, listening skills are one of the main language skills. According to some opinions, in the article, listening as a process of language is interpreted into the mind. In other words, listening is a type of listening, and listening that asks for mental awareness effort. And so it will become listening learning. And when we teaching later, teacher will give English teaching, and then the student listen the material. After that, some questions are asked about what has been taught, whether you understand it or not. And then, if anyone already understand, will be categorized it into slow learner. And if you already know if anyone does not understand, will be categorized into slow learner. If you already know the research, it will be explained again sooner or later until all students understand what the teacher are explained. So that's our presentation about psycholinguistic. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.